Let's look at the question. Number of provinces. There are n cities. Some of them are connected, while some of them are not. If city A is connected directly with city B, and the city B is connected directly with city C, and then the city A is connected indirectly with city C, and it gives us the definition. A province is a group of directly or indirectly connected cities and no other cities outside of the group. We are given an n multiply n matrix. The function is connected. So if the I city and j city are directly connected, then the function is connected at I and j is 1. So otherwise, if the I city and j city are indirectly connected or they are not connected, then the function is connected at I and j is 0. And finally, we just return the total number of provinces. The given matrix can be viewed as the adjacency matrix of a graph. Just by viewing the matrix in such manner, our problem reduces to the problem of finding the number of connected components in an undirected graph. So, in order to understand the above statement, we should consider the example matrix like this. So if we view the matrix M as the adjacency matrix of a graph, then we can form a graph like this. In this graph, the node numbers represent the indices in the matrix M, and if there is 1 in the corresponding M at I and j, then there must be an edge exist between the nodes numbered I and j. So in an undirected graph, in order to find the number of connected components, one of the simplest methods is to make use of the deep first search starting from every node. We just try to make use of the visited array, which size is capital N, and we should remember the matrix M is the size of capital N multiplied by capital N. So we're undergoing a deep first search from some nodes. The visited at I element is used to indicate that the ith node has already been visited. So if we try to undergo depth first search, we first pick up a node and visit all its directly connected nodes, but as soon as we visit any of those nodes, we recursively apply the same process to them as well. So thus, we're starting from a current node first, and then we try to go as deeper as possible into the levels of the graph. Then we just leaving the other directly neighbor nodes to be visited later on. So from a graph, we can see that the components which are connected can be reached starting from any single node of a connected group. Thus, if we try to find the number of connected components, we have to start from every node that we isn't visiting right now, but we just apply the depth first search starting with it, and then we just increment the count of the connected component for every new starting node. So let's say the example, we have 0, 1, 2, 3, 4, 5. First we check the 0 and 1 connected, so we deep search in the 1. 1 and 0 connected, 1 and 2 not connected, 1 and 3 not connected, 1 and 4 not connected, 1 and 5 not connected, and then we go back to 0. 0 and 2 not connected, 0 and 3 not connected, 0 and 4 not connected, 0 and 5 not connected. Because we already checked the 0 and 1, so let's start check 2. 2 and 0 is not connected, 2 and 1 is not connected, 2 and 3 is connected. So we deep search in 3. 3 and 0 is not connected, 3 and 1 is not connected, 3 and 2 is connected, but we visited before. 3 and 4 is not connected, 3 and 5 is not connected. After finish 3, we should go back to 2. Check the 2 and 4 is connected. So let's deep search in 4. 4 and 0 is not connected, 4 and 1 is not connected, 4 and 2 is connected, but we visited before. 4 and 3 is not connected, 4 and 5 is not connected. After we finish 4, we should go back to check the 2. 2 have a final check, 2 and 5 is not connected, so we are done. So we already checked the 0, 1, 2, 3, 4. Now let's check the final 5. 5 and 0 is not connected, 5 and 1 is not connected, 5 and 2 is not connected, 5 and 3 is not connected, 5 and 4 is not connected. So how many connections we have? We have 0 and 1, we have 2, 3 and 4, and we have 5. So there is 5 connections, so the count is 3. And let's analyze the complexity. The time complexity is O of n squared because the complete matrix of the size is n squared, which is we traversed. And the space complexity is O of n because we just visited the array of size of n, so the n space is used. So let's try to define the function find circle numbers. I is initialized to 0 and we can round the 0 with 0, 1, 2, 3, 4, 5 with the deep first search. First we check 0 and 0 is connected with itself. So we check 0 with 0, 1, 2, 3, 4, 5. 0 and 0 is visited before. 0 and 1 is connected, so we deep search in the 1. So let's do the third deep first search on 1 compare with 1 and 0, 1, 2, 3, 4, 5. First we compare with 1 and 0 is visited before, 1 and 1 is visited before, 1 and 2 is not connected, 1 and 3 is not connected, 1 and 4 is not connected, 1 and 5 is not connected. So after we finish in the third floor, we go back to the second floor. We compare the 0 with 2. Is not connected, 0 with 3 is not connected, 0 with 4 is not connected, 0 with 5 is not connected. After we finish search on the second floor, we go back to the first floor. We come back to the 0 with 1 is not connected, 0 with 2 is not connected, 0 with 3 is not connected, 0 with 4 is not connected, 0 with 5 is not connected. So after we finish the find circle number function, we just increment the count from 0 to 1. Now the count is 1. So because we already checked the index 0 and 1, so we will mark it with the visited value 1 in the visited array. We should check the I is 1, but we visited before, so we keep move on. We start check with I with 2. So we compare the 2 with 0, 1, 2, 3, 4, 5, 2 and 0 is not connected, 2 and 1 is not connected, 2 and 2 is connected itself. So we compare 2 with 0, 1, 2, 3, 4, 5. 2 and 0 is not connected, 2 and 1 is not connected, 2 and 2 is visited before, and 2 and 3 is connected, so we keep moving on deep first search into 3. 3 and 0 is not connected, 3 and 1 is not connected, 3 and 2 is visited before, 3 and 3 is visited before, and 3 and 4 is not connected, 3 and 5 is not connected, so we go back to the second floor. From the third floor, we compare the 2 with 4. And because 2 and 4 is connected, so we keep deep searching the 4, compare 4 with 0, 1, 2, 3, 4, 5. 4 and 0 is not connected, 4 and 1 is not connected, 4 and 2 is visited, 4 and 3 is not connected, 4 and 4 is visited, 4 and 5 is not connected. After we finish search in the third floor, we go back to the second floor. We compare the 2 with 5 is not connected. After we finish the second floor, we go back to the first floor. We compare the 2 with 3 is not connected, 2 and 4 is not connected, 2 and 5 is not connected. So after we finish the find circle number function, now we increment the count variable from 1 to 2. Now the count is 2. So let's update the visited array, which is 1, 1, 1, 1, 1, and 0. The first 5 element is 1. So we skip the index is 3, but skip to the index is 5, and then we compare it with the j in the for loop, which is 0, 1, 2, 3, 4, 5. So we check the connection. 5 and 0 is not connected, 5 and 2 is not connected, 5 and 3 is not connected, 5 and 4 is not connected, 5 and 5 is connected with itself. So we compare the 5 with 0, 1, 2, 3, 5 and 0 is not connected, 5 and 1 is not connected, 5 and 2 is not connected, 5 and 3 is not connected, 5 and 4 is not connected, 5 and 5 checked before, so we just increment our count from 2 to 3. And then we update our visited array, which is 1, 1, 1, 1, 1. So we already checked all of the index. Then we finish our program. We just return the count, which is 3. So let's start the algorithm in Python. First, we declare class solution. Then we define the main function, which is define find circle number. which is self, and capital M represent the matrix we want to input. In this case, is this matrix. And then we initialize the visited, which record which index we visited before, which is in the default value is 0, represent we never visited before, and multiply by the length m, which is 6 in this case. And so if it become 1, that means we visited before. And then we declare another variable count, initialize it to 0, means there's no group, no connected vertex from a group. And then let's start our for loop. For I represent index, in this case 0, 1, 2, 3, 4, 5, which is our row, in range length n. So the I is the outside loop, the loop from first row to second row. If the visited at I is 0, means we never visited before. If we never visited before, we just run a deep first search, self.deep first search. We input the capital M represent the matrix and the visited array, which will record what we visited. We should take it as a reference, and then is the I represent the index. It will tell us which index we are in, current now. We are pointing current now. And then after this finished, if it meet the condition, we just increment the count by 1. That means this for loop is we meet a one connected group. Then after finish the main function, we just return count, which is how many connected group we have. So before we run this, we should define our basic algorithm, which is define deep first search self, and capital M represents the matrix, and visited represents what index we visited, and is I, which pointed the current row we have. So if we know the current row, in the same row we have to run a for j in range from 0 to length m, which is the first column, second column, blah blah until 6th column. So which is j. We just run if m at I at j is 1 represent it is connected, but we have to make sure it is never visited before. So visited at j is also should equal to 0, right? So if meet both condition, we just mark it visited. Visited at j is become 1. That's marked as visited. Then we have to do recursively deep first search, which is self.deep first search. Capital M represents the matrix, and visited, which is record our visited index as our reference, and then it's j. We recursively run this deep first search until if it is 0, if m at I at j is 0, that means it is not connected or visited. J is 1, that means we visited before. So in that situation, we will stop the recursively deep first search. Yeah, the result is 3. That's right.